17. For the exponential function f, the value of f of 0 is c, where c is a constant. Of the following equations that define the function f, which equation shows the value of c as the coefficient or the base? This type of problem has showed up before, and it usually sends people into like a little bit of a whirlwind going, what is going on? Because this isn't a format that you normally see in a math class. Okay, all of these functions have the same value. They all do. That's what this part means. When it says, for this function f, the value of f of 0 is c, where c is a constant. Of the following equations that define the function f, all of them define the function f. All of these are the same. And you can see this by plugging in 0 for x. So if you did 22 times 1.5 to the power of 0 plus 1, or if you did 33 times 1.5 to the power of 0, or 49.5 to the power of 1.5 times 0 minus 1, or negative 1, or if you did 74.25 times 1.5 to the power of 1 minus 2, or, 0 minus 2, or negative 2. If you put these into your calculator, you will get the same answer. You will get a constant, the same number every single time. So what is that constant? You don't actually have to use your calculator. You might think like, what are you talking about? 74.25 times 1.5 to the power of negative 2? Oh, I'm using my calculator. And if it was just this one, I would totally agree with you. But we've got this one right here. Anything besides 0 to the power of 0 is going to be 1. So since it's 1.5 to the power of 0, that's just 1. 33 times 1 is 33. I don't need my calculator. Save myself a little time. And I already know now it says that all of these, when you put 0 in, you get the same constant, c. This is c. C being what you get when you plug in 0 and you do the math. So now, okay, we know c is our constant. C is 33. So what is the question? Which equation shows the value of c as the coefficient or the base? The coefficient on all of these is the number that's out here that's multiplying by the number that's going to the power. And what is the number that goes to the power? That is the base. So each of these has 1.5 as the base of its little exponential. And then it has a coefficient out front. For A, the coefficient is 22, B, it's 33, etc. So it's saying which of these has 33 as its coefficient or its base? That would be this one right here. It has 33 as the coefficient. None of them have it as the base. They all have 1.5 as the base. And then we just look at the coefficients. 33. There it is. B is my answer. Again, this is an oddball, but I've seen it before. I've seen this exact format where it's, here's 4 functions and they all have exponentials of x and x minus 1 and x minus 2, and which shows this is the value. And yeah, it's one of those, it doesn't look like anything you're likely to have seen before in math, so it can be kind of like, what? So it's a good one to practice and recognize because they've done it before, they'll likely do it again. Hey guys, the full insanely comprehensive SAT math prep course I've been promising for so long is live right now at mathwithalyssa.com. You can use coupon code EOY2025, that stands for end of year, EOY2025 for 30% off until Friday, May 16th. And of course, you can also still get the free 10 video course on SAT tips and tricks at mathwithalyssa.com as well. You also can now book one-on-one tutoring sessions with me. Links to how you can do that are in the description and the pinned comment below. And as always, if the video you just watched was helpful or useful in any way, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for watching. Hope you have a great day. See you later. Bye.